Every car on this highway is moving forward. But the traffic jam is moving backward, reaching drivers who are nowhere near the original slowdown. That sounds impossible only if we imagine the jam as a physical object. Watch one point on the road. A car reaches the back of the jam, slows, crawls through it, then accelerates out of the front. The next car does the same. The cars move forward. The boundary where cars begin braking is handed backward from one car to the next. This is not just a diagram. In a 2008 experiment, researchers placed 22 cars on a 230-meter circular track. Drivers tried to hold about 30 kilometers per hour with even spacing. There was no merge, traffic light, or crash. Yet, tiny fluctuations grew into a stop-and-go jam. Here is a deliberately simple model. Cars are crowded but moving at 60 kilometers per hour. One driver briefly eases down to 55. During the following driver's reaction time, the gap keeps shrinking. To restore a safe gap, that driver brakes a little more. The next driver sees the change later and may brake harder again. In our toy sequence, 55 becomes 50, then 42, then 30. The exact numbers are illustrative. The mechanism is delayed car following, turning one small disturbance into a larger speed oscillation. Now mark the slow region instead of one car. At each moment, every vehicle has moved forward along the road. But the newest car to enter the slow region is farther upstream. That is what travels backward. The pattern of compression, not the metal. Traffic engineers describe each side of that moving boundary with density, the number of cars per kilometer, and flow, the number passing a point each hour. Ahead of the boundary, cars are packed tightly, and only a few get through. Behind it, they are farther apart and arriving faster. Take a free state carrying 1,800 cars per hour at 30 cars per kilometer and a congested state carrying 600 at 120. Conservation gives the boundary speed, change in flow divided by change in density. That is minus 13.3 kilometers per hour. The minus sign means upstream, backward along the road. The instability is not inevitable in every crowded stream. In later ring road experiments, one specially controlled car drove smoothly instead of copying every accelerate brake pulse. It opened a buffer, absorbed the oscillation, and damped the wave behind it. A human driver can use the same idea cautiously, leave a usable gap, look beyond the nearest bumper, and avoid racing toward the next brake light. The goal is not to drive slowly. It is to make smaller, earlier speed changes, so one disturbance is not passed backward at full strength. But this does not explain every jam. Real roads have merges, lane changes, signals, crashes, hills, weather, trucks, and demand that can simply exceed capacity. The ring experiment isolates one mechanism, and the simple shock calculation averages many different drivers into two states. Safety and actual road conditions always come first. So when cars move forward but a jam moves backward, track the boundary. Cars enter it from behind and leave it ahead. Reaction delays can amplify it, conservation predicts its direction, and smoother following can sometimes weaken it. The vehicles carry the wave forward through themselves and pass the pattern backward down the road.